He's pouring a pitcher of water into a glass that's more than a foot away. You can do it too. Would you like to know how it works and how you can do it? Then keep watching, because this is
Junior Science.
On today's Junior Science program, exciting experiments with surface tension with Dr. Gerald Wendt.
Hello, young neighbors. Welcome to Junior Science. Tell me, have you ever blown soap bubbles? I'm sure you have. I know I did many times. Well, did you ever wonder why the soap formed a round bubble? Why it didn't come out square or flat? Well, today we're going to find out. And while we're at it, we'll also find out how soap cleans. And we'll also learn how to make a toy boat that uses for fuel a little piece of soap. How do all these things tie together? Well, they all have to do with a very strange quality that water has. What is it? Well, let's do an experiment and find out. We know that metal is heavier than water, and when a piece of solid metal is dropped into water, it sinks. But there is a way in which a solid piece of metal can be made to float on water. First, let's do it with a needle. If you just drop a needle into water, it sinks. But if you place it carefully on top of the water, it floats. In the same way, though steel is 8 times as heavy as water, you can make a steel razor blade float. The reason for this is that water is made of tiny particles called molecules, and the molecules of water near the surface hug each other very tightly and form a sort of film or skin on top of the water. The needle and the razor blade are too light to break the film. They float on the water and not in the water. This tendency for the top of a liquid to form a skin is called surface tension. Now, if you don't believe that water forms a surface film, you can prove it for yourself. My friend here is going to show us how. All you need is a saucer, a glass, and a pitcher of water. First, fill the glass with water. Now the glass is full, but you can still put more water into it. Try. Still more. There. Well, you did it. But do you know why? Well, let's take a good close look. You were able to pile water up above the top of the glass because the molecules of water try to hold onto each other and form a skin on top of the water. Now here's something even more amazing. Take some coins out of your pocket and drop them in the glass edgewise. The water still doesn't flow over the edge of the glass. That's pretty good. But now let's add a few keys. Oh, take a chance. You'll be surprised to see how much you can drop in without making the water overflow. And all because the skin that the water forms on top of itself keeps the water in. Now, pay attention to this one, because this is a very surprising stunt. And the only reason you can do it is that the water molecules try to hold on to each other. First, get a small pitcher of water. Then lay a wet string from the handle of the pitcher to its spout and stretch it to a glass. Now, you can actually pour water along the string for quite a distance. The reason? Well, the molecules of water in the pitcher are attracted to the molecules of water on the wet string and hold on to them. Now, another thing you should know about surface tension is that its pull is the same in all directions. A soap bubble is always round because all parts of the surface of the bubble are pulled equally toward the center. And here's an experiment you can do which will show you that the pull of surface tension is the same in all directions, and therefore, whenever it can, it pulls the liquid into a round shape. This time, the liquid will be oil. First, take some water in a container, add an equal amount of alcohol, and stir. Then get a bottle of ordinary cooking oil and, with a medicine dropper, squeeze a little oil into the water and alcohol mixture. Now watch what happens to the oil. The little molecules of oil attract each other toward the center. The pull is the same on all parts of the oil, so it forms a round shape. The reason we added alcohol to the water, by the way, was to make the water less dense, to thin it out, so that the oil would not float on top of it. Now that we know how surface tension skins are formed, let's see if we can break them. What we want to do is to make the molecules of water near the surface let go of each other. And there are a lot of things that can make them do it. One of them is soap. As a matter of fact, one of the ways in which soap cleans things is by breaking surface tension. You see, dirt sticks to things chiefly because the things have a film of oil on them. And oil and water won't mix because the surface tension of each keeps them apart. Water alone can't get under the oil, so it is very hard for it to remove dirt all by itself. Your skin gets dirty because it has a thin film of oil on it, and the dirt sticks to the oil. Plain water has surface tension and can't wet the oily surface of your skin well enough to remove the dirt. But when you add soap, it's a different story. Here's an experiment you can do to show yourself the way the soap does it. Find a very smooth enameled surface and pour some water on it. Because water has surface tension, it doesn't wet the surface, but breaks up into small globules. But just get some soap, and then try. The soap breaks the surface tension of the water, and the water then wets the smooth surface and cleans it easily. Here's another way to see that soap breaks surface tension. Take a large plate filled with clean, cold water and sprinkle the surface with talcum powder. Now we're going to dip a piece of soap in one edge of the water. The soap will break the surface tension near it, and the skin on the water at the other end pulls the talcum there. Now that we know something about surface tension, let's have some fun with it. What do you say? We're going to make a mystery boat. It's a mystery boat because nobody but you will know how it works. Here's how you make it. First, cut a piece of cardboard into the shape of a boat and make a little notch in its stern. Cut out a bit of soap and put it in the notch. Now your boat is ready. Set it in a pan of water, and mysteriously it starts to move. What makes it go? That's right. The soap breaks the surface tension at the back of the boat, and the skin on the water at the front of the boat pulls the boat forward. The boat continues to move mysteriously until the whole surface of the water has been weakened by the soap. So, you see, you can have a lot of fun with science and at the same time find out how and why things work. Now, I'll be back in just a moment to tell you about next week's Junior Science.
Junior Science.